This is going to be the last problem for this unit, and for this problem, you're going to have to use all the things you've learned so far to solve an acceleration problem in 2 dimensions. So imagine someone with a life-size catapult wants to shoot a rock over a wall, and the catapult is going to be 280 meters away from the wall, and the wall is going to be 35 meters high. It's a very tall wall. And for the purpose of this problem, the catapult operator knows the catapult can shoot the rock going upwards at 40 meters per second, but doesn't know how fast the catapult is going to shoot it forward. That's an unknown quantity, also in meters per second. And it's your job to figure out how fast it needs to be going forward to clear the top of the wall without hitting it. So pause the video, try to solve this one through. Remember, you need to take all your variables and all the equations that you know and try to solve for them before you can get the final answer. And then we'll work through it together. Okay, so let's look at what we've got. Let's start by looking through our variables. We know our velocity in the y direction is 40 meters per second to start. Velocity in the x is unknown. That's what we're trying to solve for. X position is 0. X final is going to be 280 meters away. Y original is also 0. Y final, though, is not 0 like we're used to. This time it's 35. Acceleration, we'll say acceleration is negative 10 meters per second squared. If you ever have to calculate something in the real world, you should use a more accurate number than that. But for a physics problem, all that matters is that you understand it. That makes the math a little easier. And time, we don't know how long this is going to take. So let's go through and try to solve it step by step. Let's start by looking at time. The time from the bottom to the top is fairly simple, right? There's a change in velocity. The bottom is going 40 meters per second. At the top, it's going 0 meters per second for reasons we've discussed in earlier videos. So that's a change in velocity of negative 40 meters per second. We know that change in velocity is acceleration times time. So change in velocity divided by acceleration equals time. And in this case, negative 40 divided by negative 10 is 4. So 4 seconds is our time. Now that's the time to the top. How much time does it take to come back down again? Let's look at this again. In previous lectures, we've assumed that the time to go up equals the time to go down. But that's because they were covering the same distance. Here it's not quite so simple. Here we're going up to whatever the peak is, but we're only coming down to 35 meters. So it looks like the first thing we have to do is figure out where the peak is. And then from there we can use the free fall equations to figure out what the time is. So what equation is good for looking at the peak? We need something incorporating velocity, because we're given that. Probably original velocity also. Something involving change in x position, and involving acceleration, but not involving time. So what equation do we have meeting those requirements? Pretty obviously, velocity squared equals velocity original squared plus 2ax. So let's go through and see what that gives us. Velocity squared, that's the velocity at the top, so 0. Velocity original squared, that's the velocity at the bottom, so 1600, plus 2 times 10 times x. So let's go through and try to solve that. That'd be 0 equals 1600 minus 20. And that should be negative 10 in the last equation, because gravity's going downwards, times x. So let's add 20x to both sides. 20x equals 1600. So dividing through, x equals 80. Now that we know the maximum height, now we can start doing the free fall equation, because the free fall equation needs x, which is the position at the end. We can say that's 35, equals x original, that's 80, plus velocity original. Velocity original is 0, so anything multiplied by that is also 0. So we'll skip that term and go right to 1/2 acceleration is negative 10 times squared. So this, we can solve this for the time it takes to fall back down again. 35 minus 80 is negative 45 equals negative 5, because 1/2 of negative 10, t squared, divided by negative 5, t equals 9, or that's t squared, so t equals 3. Technically, we could also say t equals negative 3, but that makes no sense, so we'll omit that one. So we say it takes 4 seconds to go up and 3 seconds to come down. And this is, now that we've solved this, now we're on to the easy part. Time is 7 seconds total. And there's a pretty simple equation for relating velocity in the x direction to time. That's velocity in the x direction times time equals change in the x position X original is 0, X final is 280, so change in X is 280. Time is 70, so we can say that time is 7, sorry, so 7 seconds times the velocity in the X direction was 280 meters. Dividing through by 7 seconds, we end up with the velocity in the X direction is 40 meters per second. So as it turns out, the velocity in the X direction is the same as the velocity in the Y direction. And if we wanted to, we could go back and prove that this is true for everything. Calculate how long it takes to get to the top, how long it takes to fall back down, because we have all that information now. And if you want to check, you can go back and do that on your own. But this is the right answer. And if you can do this, you can do pretty much any problem that gets thrown at you. You just have to remember sometimes you have to combine equations and pick the one that makes the most sense.